You might be surprised to know something. The air around us has weight. Lots of weight. In fact, the atmosphere is like a giant blanket that wraps around our planet, and it's heavier than you might think. It might feel light, but all the air above us presses down with a lot of force. This force is something we experience every day, even though we don't usually notice it. We call this force air pressure. Air pressure is measured using instruments like barometers, which help us understand how much weight the air is exerting on us. Imagine a big elephant standing on your head. It sounds impossible, right? But that's the kind of pressure we're talking about. That's how much pressure the air above you creates. The weight of the air is equivalent to having an elephant pressing down on you. So why aren't we crushed like a pancake by all that weight? It's because our bodies are designed to handle this pressure. The answer is that the air pushes on us from all directions, not just from above. This balanced pressure means we don't feel the weight as a crushing force. Instead, it's evenly distributed around us, allowing us to move and breathe comfortably. Every time we take a breath, we're interacting with this invisible force. The air pressure helps us breathe and keeps our bodies functioning properly. So next time you feel the wind on your face or see the clouds drifting by, remember the incredible weight of the sky above you. It's a reminder of the unseen forces that shape our world. Think about diving into a swimming pool. You feel the water pushing on you from every side. Air pressure is similar. The air pushes on our front, back, sides, top, and even bottom. This pressure is equal in all directions. It's like being hugged by a giant squishy pillow. This air hug is what keeps us from being flattened by the weight of the atmosphere. Our bodies are pretty amazing. They have learned to live with this constant air pressure. In fact, we have air pressure inside our bodies too. This internal pressure pushes outward with the same force that the atmosphere pushes inward. It's like an invisible tug-of-war that's always in perfect balance. This balance is why we don't feel the weight of the atmosphere crushing us. It's already balanced from the inside. Section 4, Up, and Away, Altitude's Effect. Have you ever been in a plane, gazing out the window as the world below shrinks away? Or perhaps you've embarked on a thrilling hike, ascending a towering mountain. During these adventures, you might have noticed your ears popping, a curious sensation that can be quite uncomfortable. This happens because air pressure changes as we go higher. The higher we go, the more significant these changes become. As we ascend, the air becomes thinner and less dense. There are fewer air molecules above us, which means the air is less crowded. Consequently, there's less weight pushing down on us from above. This results in a decrease in air pressure as we climb higher into the sky or up a mountain. Our ears pop because the air pressure inside our ears needs to adjust to the lower pressure outside. This adjustment can be facilitated by yawning, swallowing, or chewing gum, which helps equalize the pressure and alleviate discomfort. At higher altitudes, not only does the air pressure drop, but the oxygen levels also decrease, making it harder to breathe. This is why airplanes are pressurized and why climbers often carry oxygen tanks. Understanding how altitude affects us helps us prepare better for high-altitude adventures, ensuring we stay safe and comfortable whether we're flying high or climbing peaks. Section 5, Suits for Space. Speaking of low pressure, imagine going all the way up into space. The journey begins with a powerful rocket launch, propelling astronauts through the atmosphere and into the vast expanse of space. There's almost no air at all in space, which means there's almost no air pressure. In the vacuum of space, the absence of air pressure presents a unique set of challenges for human survival. This is a big problem for astronauts. They need to perform complex tasks outside their spacecraft, often for extended periods, and the lack of air pressure can be life-threatening. Remember that our bodies are used to a certain amount of pressure. On Earth, we are constantly surrounded by atmospheric pressure, which our bodies have adapted to over millions of years. Without that pressure, bad things can happen. For instance, in a vacuum, a balloon will expand and eventually pop due to the lack of external pressure. Similarly, our bodies would face severe consequences without the right protection. That's why astronauts wear special suits. These suits are meticulously designed to provide the necessary pressure and protection, ensuring that astronauts can safely carry out their missions. These suits create a pressurized environment that mimics the air pressure we're used to on Earth. They are equipped with layers of material that offer insulation, radiation protection, and a stable internal pressure. Without these suits, astronauts wouldn't survive in the vacuum of space. The suits are not just clothing, They are life support systems that enable humans to explore and work in the harshest environment known to man. Thanks to these advanced suits, astronauts can conduct scientific experiments, repair spacecraft, and even explore the lunar surface. The development of these suits represents a remarkable achievement in human ingenuity and engineering. As we look to the future, these suits will continue to evolve, enabling humans to venture further into space, perhaps one day setting foot on Mars and beyond. The journey of space exploration is just beginning, and the suits for space are a crucial part of that adventure.